Good morning, good afternoon, and good evening. Welcome, everyone, to the IEEE Computer Society Standards Activity Board webinar series. My name is Leila De Floriani, and I'm the 2020 president of the IEEE Computer Society. This webinar series focuses on the work of the IEEE Computer Society Standards Activity Board, how these standards have shaped the work and fit into the framework of the computer society as a whole. The IEEE Computer Society is made up of more than 100,000 computer scientists and IT professionals in 168 countries driving technological innovation. We are the largest of over 35 societies within IEEE and are known for our world-renowned publications, conferences, and standards that cover all spectrums of computing and technology. Today's webinar focuses on our standards program. As you are aware, our standards enable worldwide implementation of technologies that have transformed daily life around the globe. The Computer Society currently has 250 active standards. Standard development within the society is carried out by 14 standards committees and 95 working groups. Our world-class standards range from system and software engineering to the IEEE 802 family of standards, along with cloud computing, design automation, information assurance, and test technology, just to name a few. Before I pass the microphone to today's host, I want to thank the Standard Activity Board Vice President, Riccardo Mariani, and Vice Chair, Ritu Sethi, for organizing and putting on this monthly webinar to help us understand the standard development process and gain insight into the importance of our standards program. I also would like to thank our dedicated IEEE Computer Society staff for all their help in putting on this monthly webinar series, so we can share this vital information with you. Now, without further ado, let's go to today's host to explain more about what our Standard Activity Board does and today's topic.
Thank you, Leela, for kicking off today's webinar. My name is Ritu Sethi, and I'm the Vice Chair of the Standards Activity Board. I'll be your webinar moderator for today. Before we get started, I'd like to take care of some housekeeping items out of the way. The webinar is being recorded, and the slides and the recording will be made available after the webinar. You can ask your questions in the question and answer panel. Today's presenters will answer as many questions as possible following today's presentation. Since we have two speakers today, if you have a question related directly to what they've covered, please address the question to them when you type it in the chat box. Otherwise, we'll leave it open for either of them to answer. And if your question is relating to a particular slide, please do your best to reference that slide. Let me also quickly briefly introduce you to this IEEE CS Standards Activity Board mission and the various active standard committee that it foresees. So the CS Standards Activity Boards, the main mission is to encourage computer society members to participate in standardization activities and to promote the use of IEEE standards and to develop useful products that leverage IEEE standards within the scope of the computer society. Moreover, the mission of SAB is to promote and foster industry participation and engagement through standards, but also through other activities. The SAB accomplishes this by working with the other IEEE Computer Society boards and committees to provide standards leadership, helping to ensure the vitality and success of IEEE Computer Society Standard Committee sponsors, and helping to establish new standard activities in response to changes and advances in the computing profession. Serving as a sponsor for standards activities for which an appropriate existing sponsor does not exist, and Lastly, working with the other computer society boards to identify initiatives for a wider industry participation in computer society activities. Now, to take you to the CSSAB number of working committees that are active today, we have around 14 standard committees. They be listed here. We already covered the SAB Standards Committee in our last webinar, and today we are touching on the LANMAN IEEE 802 Standards Committee. This is in fact a two-part series in which we are going to cover about the 802 series of standards. Today, we're here to talk about the IEEE 802.3 Ethernet standards, and next month we touch upon the 802's wireless family of standards. Let me also briefly introduce the abstract and followed by the presenter's bio towards you. The technical standards created by the IEEE 802 Local Area Network and Metropolitan Area Network Standards Committee over the past 40 years has been essential in enabling suppliers of data communication components, products, systems, and services to be delivered economically at an immense scale. The vast, ubiquitous, mostly hidden data communications infrastructure of the Internet, both wired and wireless, relies on technologies and protocols that have been specified and continually updated by a dedicated group of engineers in the IEEE 802 LMSC. So in the first part of these two-part series, I would like to welcome Paul Nikolich, who's the chair of the IEEE 802 LMNC and who will explore the 802's wired family of Ethernet standards, along with John, who chaired the two Ethernet projects that took Ethernet from 10 gigabit Ethernet to 100 gigabit Ethernet to 400 gigabit Ethernet. The breadth of the Ethernet family and its future will also be explored. Briefly to introduce, Paul has been focusing on developing new ventures, technologies, technical standards, and intellectual property in the data communications and broadband industries as an angel investor and board member of early stage companies. He is an IEEE fellow, and since 2001, he leads the IEEE 802 LANMAN Standards Committee as chairman, overseeing 75 active technical standards and the 50 concurrent projects for wired and wireless networking applications. He's also a partner in NYAS Broadband Ventures LLC, holds several patents, serves on the boards of directors and technology advisory boards of several companies developing emerging technologies. John D'Ambrosia is a distinguished engineer at FutureWay, a U.S. subsidiary of Huawei. He is also a member of IEEE 802 Executive Committee. He chairs the IEEE P 802.3 and IEEE P 802.3 CW task forces that are developing 100 gigabit per second and 400 gigabit per second Ethernet over DWDM systems, and chairs the IEEE 802.3 New Ethernet Applications ad hoc. Previously, he's chaired the task force that developed 40 gigabit per second and 100 gigabit per second Ethernet, as well as 200 gigabit per second and 400 gigabit per second Ethernet. In addition to his multiple roles in IEEE 802, he's an advisor to the European Photonics Industry Consortium and was the chairman of the Ethernet Alliance from 2011 to 2019. His previous work experience includes Dell, Force 10 Networks, and Tyco Electronics. Welcome, Paul and John, for this presentation today. Meanwhile, let me also introduce Scott Levine with the IEEE Computer Society staff. He's also on the webinar today with us, and he'll be helping with the question and answer session. With that, let's get going with today's presentation. Paul, the floor is yours. Welcome.
Thank you very much, Ritu and Layla. We appreciate this opportunity to present some of the work that we're doing in IEEE 802. This particular series is going to focus on the 802.3 Ethernet. It appears that my video is frozen, and I apologize for that, but I will press on. I'm not sure why that is. So as I mentioned, John and I are going to be focused on explaining a little bit about what's going on within 802.3 Ethernet, which is the main working group that develops the wireline physical and MAC physical layer and media access control specifications for wireline applications. Excuse me. This graphic illustrates how we're organized. The IEEE has 5 major organizational units. The 2 that are working on standards are Technical Activities and the Standards Association. Technical Activities in blue consists of many societies and councils, of which Computer Society is one of them. And as Ritu explained, they host the standards activities through the Standards Activities Board, and one of those standards activities is indeed IEEE 802 LANMAN standards. And in parallel with that, the Standards Association is responsible for establishing the policies and procedures under which the technical standards can be developed across all the IEEE societies and councils. But as I mentioned, we're going to be focusing on 802.3, and 802 consists of approximately 750 active participants that are working on these projects, these 50 concurrent projects. We have a lot of activity. The organization meets usually in person. This year it's been almost all electronic, 6 times a year to work on this work, plus many meetings in between those face-to-face meetings. And I wanted to mention that 802 has been in business since 1980. This is our 40th anniversary. And we are very proud that 802.3 is one of the very first and most important technical standards that were developed back in the early 80s and continues to evolve to this day. Some of the success of 802 is specifically due to the fact that we focus on market-relevant activities and make sure that we produce high-quality standards to enable interoperability across a multi-vendor universe. So with that said, I'm going to hand over to John, who's going to give us an overview of the Ethernet family. John?
Thank you, Paul. It's really good to be here. I want to thank everyone for attending today and their interest in Ethernet. Many people, when you talk about Ethernet, the first thing they ask is, well, what speed? I think Ethernet is associated with the feeds and speeds mentality that's taken over this world in the past 20 years, especially right now. So this is a chart that basically shows when each of these different standards were ratified. Now, it's important to note that this is on a log scale here on the y-axis. So we're talking about how Ethernet over the past 40 years has jumped from 10 megabit per second to our current ratified standard, which is 400 gigabit per second. Those are the highest, that's the highest speed currently. And there's actually some more exciting news for beyond 400 gigabit per second, which we'll get to later on. So it's very interesting to see that normal progression, and you can see there's really 2 distinct errors there. In the first 30 years, Ethernet progressed at this normal, one speed mentality for an application. And, it went from 10 meg to 100 meg to a gig to 10. And then when we got to 10 gig, well, then things started changing. So, Paul, were you going to say something?
Yep. John, it's very clear from this graph, there appears to be 2 distinct eras in the progression of the 802.3 standards. As you mentioned, to the left, we've got single speed increments, And then to the right, we've got double speed increments. Didn't you lead the first task force to introduce more than one speed?
Well, yes, I did, Paul. That was the 802.3 BA task force that introduced 40 gig and 100 gig. Well, let's stay there for a second. The way that I would like to try to describe this and put it into everyone's mind is that in these first 30 years, Ethernet kind of progressed, and perhaps people are familiar with this, with 10 times the performance at 3 times the cost. That's how everybody knew Ethernet, and we always had this religious fervor that all of our next speed increases were based on a 10x leap. But when we got to going beyond 10 gig, something happened. And the way I would characterize it is that people recognized that for beyond 10 gig, that there were different applications, and those applications had different bandwidth growths. So we seemed processing at the time we thought was going to grow, essentially doubling every 24 months, where networking would continue to grow every 18 months. And as a result of these two different growth patterns, it was recognized that there were different bandwidth needs for different applications. So after the 2010, the way that I would describe it is that you really started to see people saying, let's focus on the right speed for the right application. So now that's actually a really good segue to how we should be now looking at Ethernet, not from a speed perspective per se, but from an application perspective. I think many of us are familiar with how Ethernet, started with its roots in the enterprise. People used to plug in their laptops to the network through the famous or infamous RJ45 connector. And that really took a lot of us, through the beginning stages of Ethernet, really the first 20 plus years. When we got to 10 gig, well, now data centers started to become very interested in the technology, and we started to see a lot of growth and progress from using that speed for 10 gig and now beyond. And that's where I said we talked about 2 new speeds, 40 and 100. Once we actually, I described the 10 times the performance leap as kind of a religious fervor, and I think that's a fair way to look at it. But once that was broken, I guess, people started to say, wow, so I don't really need to worry about trying to fit my application into what Ethernet speeds are. I could actually get an Ethernet-based standard for my particular application space. And you can see what happened there. You started to see, data centers were a big driver on the fast stuff. So always, I think they always, everybody knows that they need more bandwidth, and we're constantly in the Ethernet community trying to provide them with more bandwidth. And that's progressed to even what's called DCI, or data center interconnect. But there were other markets that came into play. So there was the access, which is getting a lot of attention in the industry today. And you can see solutions for access anywhere from 10 gig to 50 gig and combinations of those speeds. Automotive is another huge success story. And it's very interesting because, when automotive started off, they were looking at a gigabit. Then they started going essentially in both directions. It was very funny. They said they needed more bandwidth, and that's why they needed to add 10 megabit. And we kind of had to talk with them about that, and they didn't really mean bandwidth. What they meant was they needed more connectivity. And now they're looking at going beyond 10 gigabit. There's projects right now for both optical and electrical that are going to pursue going beyond 10 gigabit, but there's still a lot of those lower speeds. So even in a given application space, there's a great speed diversity. It's really about using what is the right solution for the problem. And we have to remember, you can't always count on volume to drive the cost down. There are, each application has its different cost targets and its different performance goals. So I think the automotive is a great example of that. In addition, we're seeing the industrial leveraging a lot of new Ethernet solutions that they're now looking at. And between industrial and automotive, we've now seen the famous 1,000 base T connection that is basically 4 cables, 4 differential pairs, is now 1 pair. So you're seeing, very high speeds over a single twisted pair. And I can't forget, because it's actually one of my favorites, power over Ethernet. So these cables that we're talking about, the twisted pair cabling, they can be used to deliver up to, I think the latest is 90 or 99 watts over a given cable. So you can now imagine that not only can Ethernet provide you with the data connectivity, it can also provide you with power. So, I like to look at this chart and say Ethernet is actually in all spaces going anywhere from DC to 400 gigabit per second. So you can see this huge diversity now in applications.
John, I think this slide is a really good demonstration of how the Ethernet Working Group is responding to the needs in the marketplace. We'll develop technical standards for any substantial market requirement that exists out there. On the next slide, can you go to that slide? You show all the different interfaces that have been developed to serve those markets. Can you chat about that for a little bit? It shows you the richness and complexity of the 802.3 technical standards.
Oh, absolutely. And I think one of the key things to note here is just the diversity of the solutions. What I would actually like to point out is that this chart actually shows the interfaces and technologies that are not only specific to a given application, but are also general. So when we look down here in these lower areas of the real short distances, a meter and below, we're really starting to talk now about connections between chips, chips to optical modules, and even across backplanes, and in some cases now you can see these red dots are twin-ax cables. We're even getting down into twin-ax cables where you can use those for multiple applications. So there's this huge richness even within this chart that's showing how Ethernet supports all of the applications as well as individual applications. Now we're showing a lot of different things here, and we're trying to figure out a way to make it more easy to capture, right? Because there's so much happening in there. Rather than trying to go through everything, I'd like to pick out a simple example. And I think
John, excuse me, before you do the example, I'd just like you to note for the audience the number of orders of magnitude that span the distance and the speed. We're looking at orders of magnitude, 6 orders of magnitude in distance. We're looking at 6 or 7 orders of magnitude in speed. It's just an incredible range of capabilities. Go ahead, John.
Well, I'm going to add to that. It's not just an incredible range of capabilities in terms of what the Ethernet specifications provide. I want to put a nod out to our volunteers. It's an incredible testament to all of the capabilities that the 802.3 family brings together to make all of this happen. Without our participants, we wouldn't be able to do this. So I think this chart really is a testimony not only to the Ethernet specifications, but to the participants. So let me cite that one example real quick just to illustrate something to you. So I've talked about all of the different spaces that we have. I want to focus in on 2 in particular. So the one here in the middle that's around these orange dots, and I keep putting my mouse over there thinking you can see it. It's in the very middle. It's at the 10 to 100 meter range. This is the twisted pair solutions that many of us know. I mean, quite honestly, that's how I used to tell my wife that's what I do by Ethernet, by pointing that, because that's what she was familiar with. I think all of us are familiar with that RJ45. And you look at that, and that spans 100 meters, as I said, and it goes really, I showed it to 100 meg because that's what's common today, but really 10 meg to 10 gig. So this is the Ethernet interconnect that many of us know and love that's in a lot of office spaces, enterprise, campus. It delivers the 1000 base T. It's also delivering power, the PoE that I talked about. Now that's got one set of needs. Now if you look over here all the way to the right, so as you were talking about the orders of magnitude, I've never actually calculated that, Paul, so that was kind of interesting that you did it that way. I just look at that as, whoa, those are 80 kilometers. 80 kilometers, not 100 meters. So, it's fair to say in this case that we want to run Ethernet over different applications. I talked about that before. And in this case, we want to go 80 kilometers. Now, as much as I love copper, we're not going to drive copper 80 kilometers. That really is an optical solution. And I'm going to point out then, it's not a matter of, we go back and everything changes to whatever the newest and latest thing is that we develop. DWDM systems are different than enterprise. They have different cost targets. They have different needs, and really there are different solutions and technologies that are looking at this. In the case of base T, we're looking at something running over an installed base of billions of meters of installed Cat 5e, Cat 6, and Cat 6a cabling. Where in the case of the kilometers, we're talking about DWDM systems of single mode fiber that go for very, very, very long reaches. Very different market applications, very different needs. And as you said, our mission is to provide market relevant, high quality standards.
John, so this covers where we're currently operating. Tell us a little bit about what's coming in the future. You're leading some very interesting forward-looking activities.
Well, yes, I am. What I do want to say before I jump into that, though, is I would say that right now, for the past several years, 802.3 has been just producing standard after standard in a multitude of areas. And I'm only going to touch on the one that I'm personally involved with today. I would encourage people who are interested to go and look at the 802.3 webpage, because chances are there really are a lot of new projects that you may not know about there as well, going over multi-mode fiber, access solutions, automotive, industrial, as well as other high-speed projects. So there really is what's going on, a lot going on. But as you said, I'm leading a new effort, which I kind of had to laugh when Ritu did my introduction, because things change very rapidly. And one of the things that has changed is that I am now acting chair. Be chair hopefully next month, of the recently formed Beyond 400 Gigabit per Second Ethernet Study Group. So we are going to be getting the band back together, if you will, and start addressing Ethernet for beyond 400 Gigabit per second. I think two of the candidates that are probably most talked about at this point is 800 Gigabit per second and 1.6 terabit per second. So that's going to be one of our first discussions to address, is where is Ethernet going? And you can see from this graph, I plotted just a curve fit really easily of the highest speeds. And you can see we really
John, excuse me, those are the peak speeds of the standards, right? You're just picking the fastest ones.
I am picking the maximum speed that's introduced at that time, which is more of an issue in what we call the second era, because when 100 gig was introduced, also 440 was introduced, and when 400 was introduced, 200 was introduced. So it is very likely, and that's actually one of the topics for discussion, that it may not be a choice of one or the other. We could, in essence, see both be formed. That's going to be another area of debate for the task force. I know we talk a lot about the Ethernet rates, but the real key is to understanding what is happening with the basic signaling rates that create the Ethernet rate. Where Ethernet is today in the higher speeds is just parallelization. So we have multiple lanes running at speeds that you gang together, and that essentially creates the new Ethernet pipe. But this is done with electrical interfaces, it's done with optical wavelengths, it's done with conductors, as well as lambdas. So we can use that technique of parallelization to come up with solutions. It's a way to come up with a solution before the technology actually gets there. For example, when 100 gig was first introduced, it was based electrically on 10 lanes of 10 gigabit per second. We're now working on a project to define a single 100 gig lane. So there's a way for us to achieve higher speed at the port interface before we can do it inside. So the big question when we go and look at 800 and 1.6 is, will we be making the leap from 100 gigabit per second per lane to 200 gigabit per second per lane? So that will allow us to gang things together. So you could see 800 gigabit per second created by 4 lanes of 200, or you could even imagine 1.6 created with a solution that would be 8 lanes of 200. And there's a lot of other potential solutions that could be introduced there. 800 by 2, for people who are familiar with 800 gigabit per second in coherent technologies. So we'll have a very fun and interesting debate as we look at the full Ethernet ecosystem, starting from the essentially the chip-to-chip interfaces all the way up to the DCI interconnects, and we figure out what will we be tackling with this first project for beyond 400 gigabit per second.
John, I think this graph is a really great graph because it says what we've been able to do over the past 40 years is consistently produce technical standards that support a speed increase of about doubling every 7.5 years. And we don't see that slowing down. It's quite amazing. So go ahead, John.
No, I was gonna say it really is a testament to what this group has accomplished. I've been involved with the last 3 speed changes. I was a newbie when 10 gig was being introduced, and then I wound up chairing the 100 and the 400 efforts, and now looking at the next one. And I have to say, it's just such an exciting place to sit and watch the industry come up with these solutions on how they will be able to create solutions that will essentially feed, and I think that's the right word to say, feed the public's unending thirst for more bandwidth.
So Joe, we've got a couple of questions. One of them is, what is DWDM? Dense wavelength.
Oh God.
Division multiplexing.
Division multiplexing. Thank you. Yes. So this is a way where you essentially send multiple light streams down a fiber, and each of these light streams, in general, I'm going to keep it easy. Each of these light streams represents a different connection. It's not. I talked before about the ganging approach. It's not when you're running them independent of each other. That's more DWDM technology, and it's on a 100 gigahertz grid. So that's how far apart the optical wavelengths are. In some cases, we use this technique to create a single link, and that's really a WDM solution where you're doing like 4 lambdas of 25 gigabit per second optically to go and create 100 gigabit per second pipe.
John, we have an interesting follow-on question, which is, besides parallelization, what are technical advances that allow for the increased bandwidth?
Good. It's a good question, actually. I think one of the things that we recognize, and I have, it's always amazing. You always have up different charts that you can use. And this is one of those cases. So thank you for that question. There's 4 basic axes that I always look at in terms of how can I achieve a faster pipe. One is I can go faster. I can increase the baud rate. The second is I can transmit more bits per baud. So in the case of NRZ, you think of it as simple 0, 1. You're transmitting 1 bit of information with each time cycle. When we jumped from 25 gigabit to 50 gigabit per second mainstream signaling, we went to something called PAM4. And in this case, you're transmitting 2 bits per baud. It's encoded into it. There are other techniques that are coming out that will transmit more bits per baud. We see some of this with the coherent technology that we're looking at. QAM16, for example, with 400 gigabit per second DCI. And I think as part of the modulation discussions, you also get into other techniques that you could throw in. You could throw in equalization, you could throw in forward error correction, which is one of those big ones that gains a lot more attention as we do this. And you essentially get signaling gain from how you encode the data into the data stream. And I do need to point out that as we do these new techniques, we always have to worry about latency, especially if you remember, I pointed out the data centers is one of the big places for higher speed Ethernet, and latency is not well liked there. So we really need to come up with low latency solutions. Now, the other techniques that you can do is the parallelizations, and really 2 ways that you can do that. In the copper world, it's most easily done by throwing down more conductors, right? So you can imagine 4 differential pair becomes 8 differential pair. Now, in some cases, people then go bidirectional on each of those pairs. So there's a number of different techniques that you can do. And then the last one is adding more optical lambdas in a optical fiber. Now, I know somewhat in copper, there's adding more frequencies of operation. That's a little bit beyond my pay grade at this point. But there's always more techniques out there that we can use and leverage, and that's exactly what the Ethernet community does.
John, thank you. We've got a couple more questions, and then I think we need to wrap it up. We're over time. One question is, can any of this advancing technology address the rural broadband problem? And let me handle that. There's a set of specifications in the Ethernet family that address the point-to-multipoint over fiber that could be used for the rural broadband problem, but it's really going to be solved by wireless techniques because of the very, very low densities. It's simply just too expensive to pull wired infrastructure to each of the locations that need it. So there's going to be a combination of fiber backbone complemented by wireless last mile and last 10-meter access. And the last question, John, I'm going to hand over to you. It's a bit of a in-the-weeds process question, but What is a PAR?
Okay, I'm sorry. I was trying to answer that question, and I was having a problem. PAR stands for Project Authorization Request. So what that is essentially, I'll say, the form that we have to fill out to submit and go through the approval process to get a project approved. Now, in the case of 802.3, I made mention of the fact that I'm now chairing a new study group. It will be the responsibility of that study group to develop the PAR to essentially feed up, and it goes through, we'd have to go back to your organization chart, but it has to get necessary approvals above it. And in that, we will define what the scope of the project is. What are we trying to do? Okay, and then there will be other documents that accompany the PAR along the way for various approvals. So first, at the study group phase, we'll define what the objectives are. And I should point out that in 802.3, a study group or a task force is really the errand child for 802.3. So 802.3 is responsible and delegates it to this group. So we determine what the objectives are, and as part of that, we have to answer something called the 5 criteria for a criteria for standards design, or CSD document. And this is how we justify the document. I like to think it's one of the ways that 802.3 has been able to produce, as Paul talked about, high quality, market relevant standards. So we have to answer, is there broad market potential, or are there a lot of applications? We have to answer, is it technically feasible? We have to answer if it's economically feasible. The idea of producing a standard that no one can make economically isn't very appealing. So these are 3 very key core questions. In addition, we have to answer distinct identity, meaning is there another way to do this, and how is it different than that approach? As well as compatibility, which is how 802 produces such, in my opinion, high quality standards. We do have a focus on the compatibility of how the standard will be written with the rest of it. So the PAR is ultimately, though, that's the key form that you need to get approved. It goes all the way up to the IEEE SA Standards Board for final approval before a project, not a study group, before a project is officially approved and work can begin. You might want to add to that, Paul, since you're the chair of 802.
No, that's very, that's sufficient, John. I'm going to wrap it up. I'd like to just let everyone know that this is phase 1 of 2 phases. We're going to have a similar type webinar on our wireless standards coming up in January, the 20th of January. And our 2 largest groups working there are 802.11 wireless LAN, more conventionally known in the marketplace as Wi-Fi, and 802.15, which is wireless specialty networks, and they develop technical standards for things such as smart utility networks. And before I leave, I'd like to, share with you the links where you can get more information on all the things that we talked about today. And I would like to invite those people that are interested in participating in 802 standards to get involved. There is no barrier to entry. Anybody that's interested and is willing to invest time in working with us on developing these standards is welcome. And this particular link has a form for you to fill out to indicate your interest. With that, we're done. I would like to express my gratitude to John and the Computer Society for allowing us to present this information. Thank you very much, everyone. Have a good day.
Bye, everyone.
All right. Thank you, John and Paul. That was a really great webinar. I think everyone learned a lot about what we're doing with 802.3. And thank you, everyone, for attending today's webinar. So as Paul mentioned, we do have the follow-up part 2 on this webinar on July 20th at 11 a.m. Eastern. We do have 2 additional webinars this week, both from our Build Your Career webinar series. The first will be on Thursday, the 17th at 11 a.m. Eastern. This webinar is titled Solutions Thinking 101 and will cover outside the box thinking and strategies by Elsa Velasco-Paul. The following day on Friday the 18th, also at 11 a.m. Eastern, we will be hosting the Fantastic 5, the 5 soft skills every technical professional should develop. And we have a very special guest speaker that day as next year's president of IEEE, Susan Cathy Land, will be joining us to share her top 5 list with us. Registration for all those is now open. You'll see a link for those to register for those in the follow-up email you'll see later tomorrow, and along with the recording of this webinar and the slides. So thank you very much, John and Paul, for joining us, and thank you for everyone for joining us today, and have a good one. Thank you. Bye.
Bye.